In the last section, we started looking into the implementation of a function that is included in one of Node's standard library modules. We were able to find the function declaration inside the Node source code, and specifically was inside the lib folder. We saw that inside the JavaScript implementation of that function, there was eventually a call to a function that came from something called process.binding. This process.binding thing right here is what serves as an actual bridge between the JavaScript side of Node and the C++ side, which is where a lot of the internal work of everything that Node does for you is actually implemented. So a lot of your code relies upon ultimately C++ code. We left off at the process.binding statement. So from process.binding is a little bit of joining up to the C++ side. So we're going to, just for a second, we're going to skip over this V8 part right here, and we're going to go look up and find on the C++ side of the Node project where the PBK df2 function is actually really truly implemented. So back over on GitHub, I'm going to go back to the root project directory. So all the way back up here at the Node project. And then this time, rather than going inside the lib directory, which is where all the JavaScript side of Node is placed, we're going to go into the src directory. So inside of here, I'll then find inside this file or folder, I'm going to find a file called, let's scroll down. Here we go, node_crypto.cc right here. Make sure you find the .cc file and not the .h1. So inside of the .cc file, you're going to find about 5,000 lines of C++ code. Yeah, 5,748 lines. So this is the entire crypto module right here. This is all the C++ code that the crypto module actually depends upon inside the C++ world. Inside this file, I'm going to scroll down immediately to the very bottom. So very down, all the way down to the very bottom. I'll then scroll back up just a little bit, and around line, yeah, here we go, 5704 or so, you're going to find what is essentially a C++ export statement. Now I know that you might not know C++ at all, and that's totally fine, but I think you can kind of get an idea of what's happening right here. This line of code is what takes the PBK df2 function that is implemented inside of this C++ file, and then somehow exports it as a function called PBK df2. So this line of code right here is what was eventually getting invoked by that process.binding line. This is what somehow joined up the JavaScript world and the C++ world, and eventually made this C++ function right here available to you on the Node side. Let's go find the actual declaration of PBK df2 inside this file. So there are like 5,000 lines of code inside of here, so I'm going to just search for it. I'm going to look for void PBK df2. And eventually, right about here we go. So this right here is where the actual real true 100% no goofing around implementation of the PBK df2 function is. This is the actual function that calculates the hash for some value that you provide to the function itself. Now there's no need for us to go through all the C++ code inside of here, but I think that you can very quickly get the idea that, yep, it looks like whenever we run that JavaScript code, it ultimately relies upon some C++ code. Now the other thing you might be kind of curious about inside of here is where V8 and libuv come into play. If I go all the way back up to the top of this file, and then again scroll down just a couple lines, around line 85 or so, you're going to start to see a lot of kind of using statements right here. They're all using V8 : and then some name. So the purpose of the V8 project inside of all this Node source code is to essentially act as the intermediary and allow values that are defined inside of JavaScript to be translated into their C++ equivalents. So all these using statements right here are importing the C++ definition of JavaScript concepts, like the C++ understanding of what JavaScript false is, or the C++ understanding of what an integer is, or null, or object, or string, or any of these other things. So this is where the V8 project actually comes into play. The V8 project is used to translate the Node.js values that you and I place inside of our different programs, like a Boolean or a function or an object and translate it into their C++ equivalents. Now libuv is also used inside this file as well, although its presence is a little bit tougher to actually detect. So inside this file, I'm going to do another search, and I'm going to search for simply UV. Now when I search for UV, I'm going to immediately start to see things called like UV thread start to appear. And if I keep on searching, I'll see other things like UV work as well. So inside this file, libuv is used for a lot of concurrency and processing constructs on the C++ side. And that's actually the topic of great discussion that we're going to go into in just a little bit as well. Okay, so I know that this has been a very deep dive, and you might not know any C++ at all, but hopefully you now have a better sense of how whenever you and I write JavaScript code and require in node modules or node libraries, they are depending upon some JavaScript definition, which eventually kind of maps up to actual C++ implementation on the other side of the node project as well. And then on the C++ side, there's a lot of interoperability between the V8 project and libuv as well. So now that we have a better idea of how node modules are actually implemented, let's take a quick break. We're going to come back in the next section and we're going to start to dive a little bit deeper into this libuv stuff. So quick break, and I'll see you in just a minute.